Okay, welcome back. Let's look into the Introduction to Science in the eScience Labs section. As you can see over, we have the menu, and there's also a glossary, and those are useful. I kind of just view that as the terminology that we need to look at, and I want to make sure you didn't miss it. That those are very helpful to get cut to the chase. So the learning objectives to identify and describe steps in the scientific method, and that's it's important. Differentiate amongst independent variables, dependent variables, and controls. And then we look at the design experiment with control group, perform calculations to convert units and determine percent error, and then we identify the components of a lab report. So what is science? And the reason I enjoy science, of course, is I really enjoy having a chance to explore some ideas and gut feels and things like that I can develop a hypothesis. So typically you make observations and then you try to come up with a hypothesis that you can test to some degree, and then you perform the experiments to either prove or disprove. But the idea is then you modify your hypothesis and then design another experiment, and you keep going through that, and it helps develop. So reading through that will be helpful. The scientific method, there's a video that you can watch that kind of goes over. But the idea is you make observations and then you analyze results, you draw conclusions, and then it goes right back. Either it goes with accepting or rejecting, and then you construct a hypothesis again, and it goes through that process. And that's really the kind of the key part of doing a laboratory experiment. Scientific investigations we make with observations, and these things you want to do, you make observations that you can test, and so those are the types of that are measurable and that can make sense to you. Quantitative observations allow you to record findings and as data, or leave little room for, well, I think, or gut feels and that sort of thing. You're actually coming up with data and that you can test and make a conclusion. So quantitative observations are generally preferred in science because they involve hard data, and that's because I can point you to this data, and this is it's important. So you could read through that section. Developing hypothesis. A testable experiment, as I mentioned. Every hypothesis, a scientist also develops a null hypothesis. And that's a testable statement that, if supported by results, indicates that the hypothesis is false. And that's fine. For example, if bacteria grown in media are added with added nutrients, then more colonies will grow than bacteria grow in media without the added nutrients. The null hypothesis is, if bacteria are grown in the media with added nutrients, then the same number of colonies will grow as bacteria grown in the media without. So that's your null. So you want to know what the contribution is of those particular ingredients. There are often ways to test a hypothesis. There's 3 guidelines that should be followed during an experiment. It must be reproducible. And the idea behind that is, replicable or reproducible, is that the test of time determines if the science is good or not, if somebody else can reproduce your work and get the same kind of results. Only one variable should be tested per experiment, and controls, in other words, controls that may affect the outcome, need to be considered. So you run a control that hasn't been exposed to the test variable of some kind. Now, having it replicable, reproducible is the way I refer to it as. Replicable is to create valid theories. In other words, the procedures must always be diligently recorded, and experiments must provide precise results. precise results are those that are very similar values over multiple trials. In contrast, accurate results are those that demonstrate what you expected to happen. You expected 3 students' test results to be 80, 67, and 100. So there is a difference between precise, and these are very similar, precise, and accurate is right on the bullseye there. So I hope that makes sense. Importance of being able to replicate, and that suppose you conduct an experiment to conclude that colonies of E. coli form in 3 days when grown in culture. However, you do not record your procedure or define exactly the variables included. That's not going to be viewed very well because you can't really concisely say or draw a conclusion. So the key to a good science is having good experimental designs and good notes, and so when you reproduce or somebody else needs to reproduce it, they can do that. And so attempts to reproduce an experiment without following the same procedure will generate unreliable results, and it's really hard to conclude that these people were able to grow things reliably to make any conclusion at all, and you want to try to improve that. So the scientific method is coming up with various observations, and then you construct your hypothesis and then you test it. Does it work? Great. You can modify it even still, or if it doesn't work, you denote that and you make some changes in your hypothesis and test it again. And that is the processing. So go through, it says number the steps according to the chart, and I want you to do that. You don't need me to do that, and then you can submit it and it'll let you know. We got a video that talks about variables. Variables are really important. Variables are defined as measurable components of an experiment. Controlling variables in an experiment allows a scientist to quantify the changes that occur. So we have 2 different types of variables. We have independent variable, and those are the scientists select to change within the experiment. For example, the time of day, amount of substrate, all can be independent variables, are used by the scientists to develop the if part of a hypothesis. And if there's a change in the independent variable, then there's a dependent variable also change. The dependent variable is those are observed in relation to the independent. So the dependent variable depends on the independent variable, and that's the way I've always remembered it. Any changes observed in the dependent variable are caused by the changes of the independent variable. So that's applying an antibiotic or some sort of treatment of some kind. In other words, they depend on the independent variable, and the dependent variable is reflected in the then part. So you can see that pretty clearly. So controls is a sample of data collected in an experiment that is not subjected to the change in the independent variable. In other words, we're not applying that independent variable. The control just sees if factors outside of the experiment are factors that may influence the experiment. And so controls must be identified to eliminate compounding changes. Controls are really important. So for example, if bacteria are grown in the media with added nutrients, then the more colonies will grow than bacteria grow in the media without added. One control would consist of colonies of bacteria cultured in the same exact conditions as the experimental colonies, with the exception that their media would not have added nutrients. That's a great control. Then you can kind of see the contribution with or without those additives, and then check it from there. Negative controls are data samples which you do not expect a change to occur, to help scientists determine that the experimental results are due to the independent variable. You just want to verify. Positive controls are data samples you expect a change to occur. You need to create a positive control for a microbial sample. To do this, you need a sterile loop to streak on an agar plate, and you know that grows well in agar. If the bacteria grow, then you assume the bacteria sample and the agar are both suitable for the experiment. If the bacteria don't grow, then you assume that the agar or the sample has been compromised. And so these things are important to kind of check out or diagnose those sorts of things. So I'll go through, and the element that a researcher changes in an experiment to observe the effects of this change is called the what? Independent variable. It's the element the researcher changes. So go through those and see what you can do. Converting segments or data is really important. Finding the units. You want to set the units up. There's 1 minute. In 1 minute, there's 60 seconds. If you want to convert this into minutes, then you can see that canceling out the seconds to the minutes, and so it would be 3,450 times 1 minute divided by 60 seconds gives you 57.5 minutes. So you can see conversions are pretty straightforward. Please watch the video and unit conversions. Those are really important. As significant digits, it must be accounted for. Significant digits are the digits in a number or an answer that describe the precision of the value. So any non-zero number 1 to 9 is always significant. So 45 has 2 significant digits. 3.99 has 3. Anytime a 0 appears between significant numbers, the 0 is significant, obviously. So if you're adding a 0.340000 and then you have the 9 out here, then it has 10 significant digits. Zeros that end numbers, the decimal points, or zeros after significant 4.00 has 4. 15000.00 has 7. So 1, 2, 3, 4, 5, 6, 7 has significant digits. Zeros that are used as placeholders before other digits are not significant digits. So we have 3 significant digits here because they're not significant. 0.000000897. So just terminology here. A 0 at the end of a number with no decimal can be a significant digit. So 6,200 can have 2, 3, 4 significant digits. 6.2 times 10 to the 4th has 6.2, has 3. 6.200 has 4 significant. So to avoid uncertainty, numbers can be written using the scientific notations, and the zeros are important when adding that. So here's some addition and multiplication problems, and what you do in working these to 4 significant digits, and go through that, and there's a knowledge check that will help you with that. And so work through those. Collecting and presenting data. We have tables that are well labeled, columns and rows. Graphs and line graphs, usually you put time at the bottom, the x, and then the y-axis is numbers or some aspect of changes that occur, and those are line graphs. Bar graphs, independent from each other, opposed to continuous series. They could be each sample is representative of something that is different, but you want to compare them. So a bar graph. Percent errors, you can see, is experimental minus the actual over the actual data, and you can watch the video and read through that looking at percent error. Usually put an error bar to indicate to the reader what would be up and back. Now I'm going to deviate on the lab notebook. You can follow the instructions for this, but I use LabWrite for writing lab reports, and that's an NC State link, and I've placed that in the folder in the student resources, And the lab write is an easy way to always write a lab report. Now I'll indicate a lab report is due for a particular activity or something that that you can, but you can work through these types of problems to see what's going on. There's a quiz. Go ahead and do that, and then lab procedures. And these are downloadable documents that you can obtain. So you have various lab exercise 1, and you can use these and provide that information and data to me. I will save these as a Word document and put this in the directory or the section there, so that it makes it easier for you to submit the answers instead of writing them. A PDF is kind of hard to do that, and so I can convert these. I have the Pro version of the software that allows you to read Adobe Acrobat, and so I will convert these for you and post those, so that way you can just enter it in with your word processor and indicate without having to take photos and handwritten stuff, and it just makes it easy. So that will be posted for you as well, so you can look for those exercises. So I just take these and convert them to a Word document, and so I export it if you have this particular program or not, and then once you can export these, it'll be done, and then I'll make available to you those documents, so you can have those to submit. So it just makes it a lot easier just than a PDF file. So I will make that available to you as time goes on. So that's pretty much it for the first lab on sort of an introduction to science. And you see the assignments, and just email them to me once you get the documents done, and just makes it a lot easier if it's in a Word format, so you don't have to do any special using a camera or something like that. So thank you, and I'll be proceeding on to the next lab 2, and we'll be starting that this week as well.